Hey class, what's going on? Today we're going to talk about properties of radicals. So we have 4 properties we'll talk about, then we'll do some practice. So first one is fractional exponent. So your exponents are fractions. This is a to the m over n power. And it's important to remember that when you're looking at this fraction, the denominator really refers to the root, what root you're taking, and then the m on the numerator refers to the power that you're raising it up to. So a couple different ways that we can write this. First, we can transfer this to the nth root of a to the m power. And then the difference between that second one and the third one is that this exponent has kind of been moved to the outside. You'll notice it's on the outside here. Essentially what we're saying is it doesn't matter if you take the root first or apply the exponent first. A lot of times I like to apply the root first so we can shrink that number down and then make it bigger. It's just easier to work with. So a couple quick examples here. 4 to the 1/2. This is kind of like a basic, that looks like 4 times 1/2. 4 to the 1/2. That's really the second root of 4 to the first power. Well, when we write second root, that's the square root. When we write first power, that's just 4, right? So the square root of 4 is equal to 2. So anytime you see the 1/2 power, that's really the square root. 27 to the 1/3 power, that's really the third root or the cube root of 27 to the first, or cube root of 27, which will give you 3. Let's see, if I have something like this, like 9 to the 3/2 power, let's rewrite that. That really means the second root, or the square root, you don't need to write that 2, of 9 to the 3rd power. So this is what I was saying, where it's good to kind of rewrite it from that middle form to the form on the right here. I don't know 9 to the 3rd power off the top of my head. I can do some math and try to figure that out, but I do know the square root of 9. So let's think about this in a different way. Let's rewrite it as the square root of 9, and then after I apply the root, the result I'm going to take to the 3rd power. And I think that's a little bit easier because the square root of 9 is easy. That's 3 to the 3rd power. And then that would be 3, that'd be 27, right? So you'd get the same thing if you cubed 9 and then took the square root. That's going to give you 27, but this is an easier way to do it. Make your numbers smaller by taking the root before you make them bigger by applying the exponent. Next one, if you have 2 roots that are the same, so you notice this index number, this root here, as long as those are the same and we have multiplication, you can combine what's under the root and multiply them and put them under the same root. So a lot of times we see this with a square root. So for example, the square root of 2 times the square root of 8. Remember, this would be the second root. We don't have to write that. It's like writing a coefficient of 1. You can just ignore it if you don't want to write it. This is really the second root of the square root of 16, which gives me positive 4. I don't do negative 4 because the root was already there. If they wanted plus or minus, they'd have plus or minus written in front of it. This works with any root. So if I have the third root, so like the third root of 2 times the third root of 4, well, that's the third root of 2 times 4, which is the third root of 8, and that would just come out to be 2. Okay, very similarly, if I have the same roots and there's division, I can write the fraction under one single root, kind of the same process as the one we just did, but with division instead of multiplication. So let's see, if I have the cubed root of 54 over the cubed root of 2. Neither one of these are perfect cubes, so you're going to be getting decimals if you were to use a calculator to figure that out. But when I do it under one root, the cubed root of 54 over 2, that's really the cubed root of 27, and that equals 3. Okay, so again, that works with cube root, that works with square root, fourth root, whatever it might be. And then this next one is just, reinforcing that if you're taking a root and applying that same power, those are going to offset and you're just left with what was under the root. So we see this most often when we're solving equations. Probably the most common example, if you have like the square root of 11 squared, those are inverse operations, right? Squaring and square rooting, you're just going to be left with what was under the root. for 11. Same thing with cubed root. If I had something like 9q, the cubed root of that to the third power, these are going to offset because of the same index number there, and that's just going to give me 9q. Q is an interesting variable to write. I don't write that very often. So that's it for the notes. I'll do a couple examples. If you feel comfortable, go ahead and log off and try these. But first, I'm going to rewrite in exponential form. So this is, remember, anytime we have a square root, it's really the second root. So I want to rewrite this as the value underneath the root raised to the, and then exponent over root. So that would be 3 to the 5 halves power. Write this in radical form. So 8 over 27. This is one that we'll be able to simplify eventually. I'm going to use a couple different properties here. This is really to the first power. So first thing I'm going to do is distribute that 2/3 to the exponent. So I have 8 to the 2/3 over 27 to the 2/3. 8 to the 2/3 really means the cubed root of 8, and then I'll apply the squared, over the cubed root of 27, and then I'll square it. So that'll give me 2 squared over 3 squared, which is 4 over 9. So if you can simplify, then go ahead and go as far as you can. Okay, a couple more here. 1 over square root of 8 times square root of 2. That's really 1 over the square root of 8 times 2, which is 16, which would just give me 1 over 4. 35, the index number is the same as the exponent. Those will offset, and you're just left with what was under the root. Lastly, since these are both to the third, or both have the same root, the third root, I'll do 24 over 3, which is 8 inside there, right? So the cubed root of 8, which just gives me 2. So you guys can do the rest for practice. Best of luck. Thanks, guys.